In my previous video, I explained the formulas that you need to know in order to solve rotational motion problems, as well as how to convert between linear quantities and rotational quantities. I showed how the rotational motion formulas are really just the rotational equivalents of the linear motion formulas that you already knew. In this video, I wanted to go over an example that shows how to apply these formulas. Let's now look at the following problem. In this problem, a carousel is at rest, and at t equals 0, it's given an angular acceleration that brings its angular velocity to 20 revolutions per minute after 5 seconds. You're asked to find three things. First, you're asked to find the average angular acceleration, then you're asked to find the total number of revolutions over these 5 seconds, and last, you're asked to find the linear velocity of a person located 2 meters from the center of the carousel. For part A, we know that the average angular acceleration is equal to the change in the angular velocity divided by the change in time. Since the carousel starts at rest and its angular velocity becomes 20 revolutions per minute, we know that the change in the angular velocity is 20 revolutions per minute. However, we'll need to convert this to radians per second. We know that angular velocity can be found in terms of radians per second by multiplying a frequency by 2 times pi. We can substitute 20 revolutions per minute multiplied by 1 minute over 60 seconds into this formula. We need to multiply the 20 revolutions per minute by 1 minute over 60 seconds since the frequency must always be in terms of revolutions per second. Plugging everything into this formula, we find that the change in angular velocity is equal to 2.1 radians per second. Now going back to the average angular acceleration formula, we can plug 2.1 radians per second in for the change in angular velocity and 5 seconds in for the change in time. This gives us a final value of 0.42 radians per second squared for the average angular acceleration. To find the total number of revolutions that the carousel makes, we can use the following formula. This is just the rotational equivalent of one of the linear motion kinematics formulas that you've learned about. Since the carousel starts from rest, we know that the initial angular velocity is 0, so we can just plug in 0 for that term. Then we can plug in the value for angular acceleration that we found in part A, as well as 5 seconds for the total time. Solving this equation, we find that the total angular displacement is 5.25 radians. However, part B of the problem asks for the total number of revolutions. Since we know that there are 2 pi radians in a single revolution, we can divide this value by 2 pi to find the number of revolutions. Doing this, we get a value of 0.84 revolutions. Finally, part C asks us to find the linear velocity of a person located 2 meters from the center of the carousel. In my previous video, I showed how we could find the linear velocity of a point on a rotating object by multiplying the radius to that point by the angular velocity of the object. Plugging in the given radius of 2 meters and the angular velocity that we found in part A, we find that the linear velocity is equal to 4.2 meters per second. I hope that this video was helpful, and if you have any questions, feel free to comment below and I'll do my best to answer them. If this video was helpful, please give it a like and consider subscribing to the channel. Thanks for watching.